This is IGCSE 0625 Physics Major in 2024 P22. These are the grade thresholds for this year out of 40 marks. A student wishes to measure accurately the volume of approximately 40 cm cube of water. He says we have two measuring cylinders. This one goes up to 100. This one goes up to 50. And he says a meniscus where it touches the glass. Now, if it is water, probably, this is water, which is colorless, and if they're colorless liquid, we go for the lower meniscus or the bottom of meniscus because we can see it. If it is a colored liquid, then the problem arises for the fact that if this is the diameter of the colored liquid and the meniscus starts like this, and I'm exaggerating the view, it's not possible to see the lower meniscus of a colored liquid. So we have to settle for a top meniscus. And we have to choose this as our starting point. But since for a colorless liquid, we can see the bottom meniscus, then we choose that as our reference because not a lot of volume is exactly in this situation. So the exact volume starts from this point. So we would be choosing bottom of the meniscus. And which measuring cylinder should we choose? Should we choose the 51 or should we choose the 101? I believe for the maximum accuracy, we should choose the smaller cylinder. It would probably have more dimensions, and if not more, then definitely more handy or better in terms of practicality because we don't need this much amount of space, and also it would be a bit heavier. So anyways, from a practical standpoint, this would be a smaller one. So the best answer for this question would be option C. Question number 2 is about motion, speed time graphs. Before we start with the question, just a reminder that the gradient of this graph represents acceleration because it's speed time graph. Same for velocity time graph. And the area would be representing the distance traveled by the object. So the question is about equal to the area. So that is going to be the average distance traveled here. So this will be option C. Question 3 is an astronaut with mass W equals to mass 80 kilograms, which is this one. So what is the weight of the astronaut? So this will be W equals to mg, which will be 80 multiplied by 3.8. If you calculate this, you will get the value of 304 newtons exactly, which up to two significant figures should be option B. Very straightforward. Sealed container has a volume of 2000 cm cube at high pressure. Top band balance to measure mass. The balance is 200 grams. He says, what's the density of the pressurized air? Now, if you notice that all the units are grams per cm cube, which means we don't have to convert the units as per se. So density is equal to mass by volume. Now, volume is straight away given to us as 2000, which is very easy to figure out. But there's a problem with mass. You see, the balance reads 200 grams today, but when the air was removed, it read 196, which means that the actual mass of air would be 4 grams. And how we got this is 200 minus 196. When you calculate this, the answer you get is going to be 0.002 grams per cm cube, which is option A. Question 5, he says, which system is in equilibrium? Now, for equilibrium, be advised, there are two conditions. Condition number 1, the resultant forces on the system should be 0, which means it shouldn't be moving in any direction. Or if it is, then there should be no acceleration in the object. So that means that the object as a whole shouldn't moving towards the right, left, up, or down. Or at least if it is moving, then the forces should be balanced. The second point we need to realize is that the torque, or that is going to be an A-level statement, so the moment of the whole system should be equal to 0, which means that there should be no physical rotation, either clockwise, neither anti-clockwise, or so opposite, right? Okay, so we have three forces. Now, what's wrong with option A? In option A, we can see that there is going to be a bit of rotation and the object would still be trying to move upwards. So it's like it's going to go like this one. It's rotating while it's going up. So the equilibrium is not established, or there's no equilibrium in this one. In option B, we can see that the object is going to eventually move in this direction, a bit anti-clockwise. It's going to settle down in this location. And as it does so, if these forces continue to exist, they will align themselves like this and then cancel each other out. And then the rod will start moving in the upwards direction. Again, no equilibrium so far. So in option C, we can see that the object tries to rotate like this, with another component helping to rotate it like this. So this is no equilibrium as well. In option D, we can see that there are two forces acting upwards, and if I measure their length by some method or even by ruler, I can see that the length added together would actually be equal to this one. Now we understand for vectors, the length of the vector represents its magnitude. So for example, if this is 10 newtons, a vector that is twice the length would generally be 20 newtons, so on and so forth in terms of the length. And since there is no counterintuitive force, there is no rotation apparently by the vector addition, simply vector addition, then this is the most likely option going to be in equilibrium. A gymnast jumps down from a high piece of apparatus. She gradually bends her knees as she lands, and this is what we generally do. If you jump from a high position to low position, generally you bend down, taking some you can say energy away from the system or your own system, and absorbing them into your knees. She gradually bends. Okay, so which effect does this have? So she will have smaller change in momentum as she lands. Okay, she will lose kinetic energy, less kinetic energy as she lands. All right, and so on and so forth. So the kinetic energy point is not fair, because if I calculate half mv square, the amount of energy she possesses will exactly be the same, and having knees being bent does not change the fact that she had this much amount of energy. She will exert small impulse on the ground as she lands. This is also a bit incorrect, because as she lands, the amount of change in momentum there is multiplied by the time of contact she has with her shoes with the ground also does not change. So not entirely accurate. She will have a small change of momentum as she lands. Not really, because if she is landing at a speed of 15 meters per second and lands completely, the speed goes down to 0 meters per second, and whatever time that may be, multiplied by the mass of the system divided by the time. So it doesn't really change the value. The magnitude of the momentum remains the same. She will experience a smaller force on the ground as she lands. So this is what we are trying to do. We are trying to increase the time of contact as we do so. So option D looks better. Question 7, he says, which table gives 4 energy sources and states of matter? Okay, source is the sun, the main source. Now this is generally sometimes a tricky question, but we understand that most of the sources on the earth, or most systems that are producing energy, they actually exist because of the sun. So geothermal, the main source is the earth's core itself. So the sun is not the source. Main source of oil, again, the main source was not the sun, but the fossil or the dead animals that actually got pressed between the layers of mountains. Water being held in a dam. So, and main source looks to be the sun. So let's discuss that later. Again, wind energy source, main source of energy is the sun. No, but it is entirely. No shouldn't have been the answer. So this is incorrect. This would have been a good answer if it had said yes. Why? Because only because of the sun we have land and sea breezes due to difference of convection current and heat capacities. That sets up a convection current, and that causes the wind. So water in the dam being held by because of the sun is a good answer. Why? Because the sun causes the water cycle to begin with. The sun causes the mountain water or the ice of the mountains to melt. We collect that into dams. It gets to the sea eventually, and then evaporates and goes to the mountains again. So it's a water cycle, which is of course because of the sun. The equation rho GH can be used for a liquid. What's the meaning of rho? It's the density of the liquid, and it's a fact. There is no denying it's a fact. So question number 9, what are correct terms for each state of changes? By the way, this is supposed to be density of the liquid and nothing else. Neither the objects placed in it or neither the object that contains the liquid. It's the density of the liquid itself. 9. Okay, so correct terms. So liquid to solid, solidification is the right answer. Liquid to gas, it would be evaporation. Common answer would be C. 10. Extremely small pollen grains in the water viewed through a microscope. The grains are seen to be moving continuously and randomly. Now, the problem is that water molecules are colorless. We couldn't see them. So what we did, we indirectly added grains of pollen or salt. Salt would be dissolved, but added grains of pollen grains or small seeds in water and just observe them under the microscope. Now, I will show you an animation for that. This is what happened when they were viewed from under the microscope. We couldn't see that with the naked eyes, but under the microscope, they definitely give us a different impression. They are being collided from all sides by water molecules like this one. So in this example, the blue particle or the blue atom is the grain, is the pollen grain, and the red ones are the water molecules being colliding from all sides randomly in all directions. That is, now, we can't see the red particles with our eyes because they are representing water. But we can see the pollen grains, which is what we did in this example. Indirectly, we have justified that water molecules must be moving randomly and colliding with the grain from all directions, which is why we see the pollen grains behave in this manner, which gave us the guarantee that water molecules are actually moving randomly. It's the water molecules that are doing that. So the grain moved randomly. Due to convection currents, no. The grain moves random rays of light, no. The grain moves random, because no. It's not because of their own atoms, it's because it is being bombarded with water molecules from all sides randomly. So this is A. Question number 11 is primarily from memory. If you remember, it's regarding volume, constant temperature, fixed mass, which means that there is no leakage of mass of gas or any particles are not leaking in the environment. And the pressure, so volume and pressure. So this is Boyle's law, P inverse proportion to volume, and from it we get P1 V1 equals to P2 V2. And the condition for using P1 V1 P2 V2 is that there is no leakage of gas and the system is at a constant temperature while these changes take place. And the straight away, the most common graph or the correct answer would be option D. Now, be advised, this is linked with the mathematics of it. The inverse proportionality graph generally is going to look like this. They've exaggerated this one a bit, but this is what it's going to look like. And also, if any of these graphs were inverted, for example, if it was something like this 1 over V with P or V with 1 over P, if any single axis was inverted, then this would be a straight line passing from the origin. That is also one of the options in option B. This would have been true if either 1 over V would have been on the y-axis or the x-axis, or either 1 over P would have been on the y or x-axis. Inverting one axis would give you this straight line. And this is again a characteristic for mathematics, that for an inverse graph, if you change one axis, then you will get a straight line. Question number 12. He says, which effect is caused by thermal expansion? So, a metal surface heating up, no, this is because of quantum physics. In quantum heating, that's not because of thermal expansion. Ice cream melting on a hot day, no, it is because of the absorption of infrared radiation, or of course, maybe conduction from the hot air around it. A railroad track buckling, yes, that is definitely a thermal expansion problem generally. Ice forming on the pond on a cold day, not really. So how does this buckling on a hot day actually take place? I will show you an animation from the channel Veritasium. They did a video on this. So the trade tracks, you will see that there are some gaps in them. And in winter, they generally shrink. And of course, the effects are exaggerated so that you understand what's actually happening. The molecules come close together and generally, like from this position to this position. And this is an undesirable effect. We don't want this to happen. And in summers, of course, due to thermal expansion, the length increases. And an average change in length observed on a 12-meter column is 6 millimeters in total, so 3 millimeters on both sides. Now, this is undesirable because considering that we have very heavy, massive trains flowing on them or moving on them, these undulations and these uncertainties add problem to the system. And now you will see what buckling actually means. So this is what buckling is. The train tracks, due to thermal expansion, completely change their shape and become this zigzag pattern. This is what causes problem. Now, in winter, if they shrink, for example, if they shrink like this, this can still be, this still is not as fatal or is not as problematic than buckling under the heat of the sun. So this, again, I'm showing this right now. This is what buckling looks like in animation, and this causes trains to topple over. This is primarily the reason. So the buckling of the train track on a hot day is one of the thermal expansion examples. Question number 13, he says, the temperature of waterfall is greater at the bottom, which is definitely the case. The energy comes from gravitational potential store at the top, transferred to the thermal store. So water is at the top of the cliff and the water is flowing down. It has a temperature T over here and a temperature over here. This is temperature initial, this is final. Final temperature is greater than initial temperature, and they're saying that the gravitational potential energy is transferred from gravitational store to kinetic store. So effectively, what we want to draw from this idea is what mathematical equation we should use to fit in the values of this question. So I will say that the gravitational potential energy store has been giving its energy to the kinetic energy store, but in this case it is not mentioning the kinetic store, is mentioning the thermal store. So we know that the thermal energy formula, this is mgh, the thermal store is Q equals to mc delta T. So I will be mentioning mc delta T over here. Now the formula is complete, and you will realize that mass cancels out from both sides. How much mass of water is flowing down. Now this is the barrier that I've experienced in my classes, that students immediately jump on the formula, that mgh. So where's the mass? Always go to the end of the question, at least try to make an equation. You will realize that the mass cancels out on both sides. So G is 9.8, height from which it was being introduced is 21 meters, 21. C is 4200. And delta T is what we're trying to find out. If you find delta T, you will realize that this comes out as 0.04905 degrees centigrade. So this will be option B. Now notice that you might be tricked into choosing option A because it's rounded off to two significant figures, but be advised this is 0.00 or 0050, whereas the true answer we get is only 10 after the decimal. So please keep your eyes open, be careful. Question number 14, he says the cube is placed in a beaker and is being heated. Okay, fine. The ice melts to form water, which evaporates at first and then boils. The steam condenses on a cold window in the room. Okay, fine. Which process involves a transfer of energy from ice, water, steam to the surrounding? So he's trying to find out that these three statements are being made. These three things are happening. In which case, the system, either ice, water, or steam, is losing energy to the surrounding. So melting, when we try to melt, we're supposed to add energy into the system. So either it's ice turning into, let's say, water, it's absorbing energy from the surrounding, it's not losing it. In evaporation, also it is absorbing energy from the surrounding, it's not losing it. It's trying to absorb energy from the surrounding so that it can break the bond and set itself free from the intermolecular forces and be in the gaseous state rather than in being a liquid state. Then we have boiling. Again, boiling requires external sources of energy. Only condensation is in which the gas molecules if they collide or if they come close to a colder surface, manage to give off their energy to the surrounding and eventually become a liquid. So this is how condensation works. Question number 15 says there are 3 cases in which there's a polystyrene cup, thick plastic walls, a lot of air bubbles. I'm expecting this is supposed to be convection question. He asks that the class why the cup is so good at keeping the hot drink warm. 3 suggestions were made. It can say air, which is a good answer. Air trapped in tiny bubbles, so very little. Now the convection part is incorrect. There are tiny bubbles. The convection part is incorrect. So, and the next one we have is the plastic is a poor thermal conductor, which is also a good answer. So this will be 1 and 3. 1 and 3 are the right answers for this one. A common example of this, again, would be from real life, is that when we wear jackets, what are the jackets or sweaters or cardigans are trying to do for you? You see, your body is releasing thermal energy. It is, of course, releasing it in form of infrared radiation. You don't want to lose that. Now, the air around your body or your skin gets warmed up. You want to trap that air close to your skin so that it stays there. We don't want to replace it with fresh supply of air, which is why we wear thicker clothes, and that's why they keep us warm. Because they trap the air. So question number 16, 2 samples of same material. When the material is same, we are absolutely sure that the thermal conduction at least would be exactly the same for all types. Different same masses with same heat content. Now why they are saying that? Because Q equals to MC delta T. They want to make sure that the heat content or the energy in both materials is exactly the same. But they're different surface areas. They have different access to infrared radiation, conduction, convection. Each sample is heated to the same initial temperature, left to cool down to room temperature. Each sample is out to cool at the same final temperature. Okay, good. Which row correctly compares and decreases the internal energy and the initial rate of cooling for each sample. So it says X loses more internal energy and X, no. Since they are going to come down to the same final temperature, the delta T is exactly the same. So if I multiply MC delta T to find the energy content, they have lost the same amount of energy. So they lose the same quantity of energy, but they do it in different ways. So initial rate of cooling, one of them will be a bit faster. So why would cool down faster? Because of its large surface area, exposure to environmental factors, more exposure to air around it, and frankly, more exposure to the infrared radiation that it can go through. So why cools down faster? It should be option D. Question number 17 is, in which type of wave the direction parallel to the vibration? So he's talking about longitudinal wave. So we're definitely looking for sound, or we're looking for seismic P waves. Now, where do the P waves come from? Yeah, if you go to the syllabus, you will realize that it's mentioned in this part. 3.1 core element 6. Know that for a longitudinal wave, the direction of vibration is parallel to the direction of propagation, and apart from sound waves and ultrasound, seismic P waves, primary waves, can be modeled as longitudinal waves. So this question is directly taken from your syllabus. Can't really do much about this. This is a fact. Electromagnetic are transverse waves, and they are electromagnetic spectrum. Seismic S wave are also transverse wave, water wave are also transverse wave. So parallel is longitudinal and longitudinal is sound or either seismic P. Again, memory-based question, can't really help you with that. 18. Ripple tank is diffracted as passed through narrow gap. What can be done to make the spreading effect due to diffraction greater? So we want to increase the effect. Now again, I will show you a part of the book. You can pause and you can read these paragraphs and you would realize that there are 2 factors. One of them is gap size, and the other one is the diffraction at an angle. You have to read this yellow bit only. The conclusion of all of that would be part A, decrease the frequency. So while keeping the wave speed constant. Yeah, see, the equation is V equals to F lambda. So if speed is constant, then that means you'll have to bring one of the variables to the other side. So lambda is inversely proportional to frequency. Now, generally, diffraction or the effect of diffraction is more prominent with a greater wavelength. This is what the book says. So we need to increase the wavelength to make the effect more prominent. Exactly same way, if we want to increase the diffraction, we want to increase the wavelength. And I can only increase the wavelength if I decrease the frequency while the speed is being kept constant. So that is why we didn't have a choice. We had to make a choice with reference to the decrease in frequency while keeping the speed constant, so that this equation stays locked in, and this equation coming from, or this idea coming from the book, can be implemented. So it's a two-part question. Question number 19. Again, can't really help you with this question much. This is a generally real-life question. He says, this is the page of the book, and the person is trying to look at this from the mirror. So whatever would be written over here would be produced over here, and the person would be looking at this image inside the plane mirror while the real image is on the outside, or the object is on the outside. But of course, I have not drawn this accurately. If I were to draw this accurately, there would be an image at this point with exactly the same distance from this point to this point. Distances are not supposed to be shown. I just did this for you guys. And of course, there will be two light rays with dotted lines on the virtual plane. One light ray up, two dotted lines, one light ray to the lower side of the eye. And then these both light rays will be joined together at a point where they originated exactly in front of the point or the object. And of course, there will be light rays originating from the object towards the eyes. That's how we see the object. The appearance would be very obvious. It's not going to be exactly the same. It's not going to be like A. It's not going to be like B. It has to be either C or D in terms of confusion. The plane mirror does not invert the image. It keeps it same, but it laterally inverts, which means the left of the image of the object will be the right of the image, and the right of the object will be left of the image. So it will be option D. Question number 20. I want to find the refractive index. So first things first, we draw the normal, and we find that this angle is going to be 30 degrees, and this angle is going to be 12 degrees. Again, normal is there for the measurement of angles. That's why it's important. So going back to the formulas, which is sine I over sine R, this will become sine 30 divided by sine 12. When you calculate this, this comes out as 2.4. Also be advised that the formula actually deals with the fact that rare medium angles come in the numerator and dense medium angle come in the denominator. That's a shortcut, that's a trick. Question number 21, converging lenses. He says which diagrams are which. So the diagram in one case is virtual because the object and the image are on the same side. And in this case, object and image are on the opposite side. So a diagram in case 2 would be real. This is a fact, so this will be option C. Question number 22, he says, this is how the prism is going to react and behave. So it says path taken. Which path is going to be taken? You see, there's a problem with diagram 1 to begin with. We will reject this diagram. We will not choose it. So we have to make a choice between diagram 2 with diagram 2. So what's wrong with this diagram? You see, any image you open up for prism, you'll realize that the moment it hits this side, the light disperses. It starts getting distributed or spreading the moment it hits a different medium. So we can see that happening over here, that it started to spread out or disperse when it reaches this point. So that's why we're going to choose diagram 2. And we have to memorize this, that the topmost color is red and the lowermost color is generally violet. Red bends the least, violet bends the most. So color 1 should be red and color 2 should be violet. So this option is option C. Question number 23 is related to uses of electromagnetic spectrum. He says, what's the name of the spectrum? Thermal radiation part of the sun. So what causes the thermal radiation from the sun? So again, this is also a fact-based question. From the sun, we are getting 3 radiations. We're getting ultraviolet, we're getting infrared, and we're getting visible light. So the highest percentage is infrared, then comes visible light, and with the smallest percentage is ultraviolet. So infrared is responsible for the thermal radiation, or what causes heating. When you stand in the sun or out in the sun, infrared is responsible for heating you up. Again, it's a fact. Question number 24. He says that the control room is this kilometers away. And what's the minimum time elapsed between the vehicle sensing the obstacle and receiving the message back? So there are two problems in this question. The first one is that there is a kilometer, there is a kilo prefix in this question, and that the distance has to be covered twice. Once the signal goes and then signal bounces back to reach the person who sent the signal. So if you're trying to find out time, this will be speed equals to distance over time, rearranging the equation. This comes out as 2 distance multiplied by 2.4 into 10 raised to the power. Now, since this is kilo and this is 10 raised to the power 6, this will become 10 raised to the power 9 as 6 plus 3 whole divided by the speed of light, which is 3 into 10 raised to the power 8. As you mentioned that this is going to be speed of light for that. He hasn't, but I think it is quite understood that if you're using a remote controller, it is most likely microwave or infrared radiation for that. So we can assume that if they're moving at the speed of light. So the time comes out as 16 seconds in this case. 25. Which statement about the direction of magnetic field at a point is correct? You see, this is also mentioned in your syllabus as a fact that whenever we draw the magnetic field, let's say this is the north pole or north of the magnet, these arrows are actually representing the direction of force on the north pole. This is 100% statement taken from the course. Question number 26. The student draws the supply for an AC and DC supply. Which row describes them correctly? So, of course, Y is the AC supply because it is alternating between positive and negative cycle, and X is the DC supply. First, let's get that out of the way. So, an AC supply would be Y, and the DC supply would be X. And it makes it very clear that W-axis is voltage. Now, if it had time would generally be on the X-axis. So, D option is the best answer. 2700 joules of energy, 10 coulombs of charge. He wants to find the potential difference. Again, standard equation from your course. Work done by charge. Work done is 100 joules. Charge is 10 joules. So 100 joules of energy being transferred by 10 coulombs of charge. Then the voltage is 10 volts. This is option B. Very straightforward. Question number 28. And this is a common question because he wants you to make sure, or he wants to make sure that you remember this equation. Another standard equation is I equals to Q by T or Q equals to IT. Students forget this in electricity and just settle down for V equals to IR and P equals to IV for electricity or electrical circuits. Wire X and Y are made from the same material, which means that the rho or the resistivity wouldn't matter in this question. So we don't need to involve that in this example. He says that there is a change in length, there's a change in cross-sectional area, and we are supposed to find out the resistance X, sorry, not X, but let's keep it Y. The resistance of wire Y, we don't know that. Okay, so how can we do that? We have the formula as R equals rho L over A. A common practice would be that first you can find what rho actually comes out to. So this is 2. So it will be 2 equals to rho. Length will be 1 divided by cross-sectional area, which will be 0.4. Yep. So rho, as from the first situation, comes out as 0.8. Now, rho is the material itself. You can solve this by a ratio method. I understand that because there is a 30% increase here, and there is approximately a decrease over here. So you can involve ratios in that, but again, I find this method easier. So resistance of Y into rho L over A. So rho is 0.8, length today is 1.3, and the cross-sectional area is 0.3. So Ry comes out as 3.467, which is 3.5. 29 is a potential divider circuit. He says the reading of the voltmeter is 1.8 volts, which means that out of 3 volts, if 1.8 is consumed by this one, then this is consuming 1.2 volts. It says what's the resistance of the resistor R. Now there are many ways to do that. I will choose the formula that's in your course, which is a ratio of voltages equal to ratio of resistances. So resistance unknown divided by the other resistance, which is 5 kilo ohms, equals to resistance ratio of voltages. So what's the voltage consumed by R, which is 1.8? What's the voltage consumed by 5K? This is going to be 1.2. Now the formula in your syllabus is written like this: R1 divided by R2 equals to V1 divided by V2. Consequently, you did definitely have another way to do that. Since you know that this is 1.8 volts, you know you can find the current in the circuit eventually. Of course, if you have the resistance, you can do that, and then probably you can backtrack your way. But again, I would advise you to use the formula. So if you take 5K over to the other side, I'm not converting K into a factor of 1000 because I can see that every option has a kilo or a symbol of K in it. So it's practically not required in this question. So when I do that, the resistance comes out as 7.5 kilo ohms. Also, what you could have done is use a potential divider rule or potential divider formula, which would have been 1.8 equals to R divided by R plus 5 multiplied by 3. Or it could have been 1.2 equals to 5 divided by R plus 5 multiplied by 3. You'll have to watch my lectures on current electricity to understand where we got these equations, but basically we are rearranging these equations for the whole system of the battery as 3 volts. But anyways, so the answer when you calculate this is going to come out as 7.5, which is option C. Question number 30. Two electrical appliances connected to the main supply. The cable connected in one appliance includes an earth wire and the other one does not. So an earth wire generally is for a metal body appliance. For a plastic body, we don't need that. And of course, it's there for safety. If a live wire accidentally comes in contact with the body of the appliance, while the person doesn't know that the body might be at live potential or at live voltage. So one appliance has metal case and the other one does not. This makes the most sense. As fitted with the fuse. Fuse has nothing to do with the metal earth wire, the metal casing. Appliance fitted with the switch, it always has to be, but the other appliance is not. No, it doesn't matter. It's not the right way. The switch always has to be there. One appliance, either metal body or non-metal body. One appliance needs more current. No, current would be entirely dependent on the power and the voltage available to that system right now or that point. So point number A seems to be the best option. Question number 31. So in question 31, it's a bit tricky. So question 31 will be one of the common questions that you will encounter in physics. So this is related to Faraday's electromagnetic induction and AC generator and the coil position. So he says that the only takeaway in this question was that the magnetic field at coil Q is 0. So students believe that there is no magnetic field passing through the coil, which they were right to think so, but we need to emphasize that the EMF or induced EMF is always proportional to the rate of change of magnetic field, which is magnetic field change divided by time. And I've done this in my lectures or lessons before, that this is primarily the speed of the magnet. If it is changing the most rapidly, then it is moving with the highest speed, and if it is doing that, then definitely it will experience the highest electromotive force. He says what statement about induced EMF in the coil is correct. So he said induced EMF at Q is larger than P, which is the right thing to say or do. The magnitude EMF Q is not 0 and never will be. The magnitude EMF Q is smaller than R. The magnitude of R and P will exactly be the same, with only one difference, that if the magnitude at P is positive, then the magnitude of R will be negative. Then they are not. Then one is not smaller than the other one. One is not larger. They're just going to have opposite signs. The magnitude of the EMF at position R is larger than at position P. No, it's exactly the same thing. So Q and R, magnitude EMF Q. No, Q is the largest one, so A is better. 32. A 24-volt power supply with 100% efficient transformer is used to light 6-volt 12-watt lamps. What is the current in the power supply? Now, this question is a bit tricky. It can confuse you. But you see, we are using a 24-volt power supply. And the bulbs that we connected is 6 volts. So 6-volt bulbs And since it is a highly efficient transformer with 12 watts of power being used, so the output power, whatever that power may be, of 12 watts of the transformer with secondary primary would also be consumed from the primary source as well. So we understand that whatever lamp is on the output, the same amount of power will be consumed on the input because it's 100% efficient. So power equals to IV, 12 watts being consumed, current unknown at 24 volts for the primary side, and the current comes out as 0.5 amperes. This is what we have to do. This is option A. The alpha scattering experiment, gold foil and evidence. Which particle scattered by the gold? This is a functional question. This is again from memory, alpha particles. X has 17 protons, 18 neutrons. So which notation is right? So for the nuclei notation, first cancel all those who don't represent 17 protons, because we understand that protons come on the lower side. So this goes out, this goes out. So we are left with C and D. Now, we understand that the number on the upper side represented by the mass number is actually an addition of protons and neutrons. So it can't be 18. It's your choice. You can add 18 with 17 and get 35, but I wouldn't go so far because I know for a fact it can't be 18. So by elimination, I will automatically land at option D. 35 was also a bit tricky. So is a dashed line is a curve to a particular isotope. The counter includes the background radiation. Background radiation is a part of this graph. So first things first, which graphs cannot be possible? So the corrected count rate is always made with a subtraction. So if I subtract values from the concentration of the count rate, my actual graph would be on the lower side of this incorrect graph, or which has a background radiation in it. So based on this idea, my new line should be below the dotted line. So option A and D are cancelled. I will not be thinking about them. When we go to option B and C, if we have to make a choice, take a guess and take a pause at this point and try to think which options would you choose. You see, option B suggests that the value or the graph still is going to carry out going downwards. And it is following this trend of our source only. The problem is that the background radiation never ends. Your source might go to 0, but your background radiation will never go to 0. So the graph will always have some value, which means that they will overlap at a certain point in time, and then the background radiation continues its life. So the chances of overlapping of these situations is only in C. Question 36. Which type of radiated source suitable for measuring and controlling thickness of aluminium or paper industry? So it is for paper, I think we choose alpha or beta. So we would choose beta because alpha would be absorbed. We want to detect it somehow. And we need long half-life. Why? Because if we choose shorter ones, the source would be consumed so quickly that we would have to replace it again and again, and it's not a good economic decision to keep it that way. So we will choose a long and beta source. But anyways, we do choose short half-life sources when human applications are involved, because we don't want human beings to stay exposed or be exposed to radiation for long periods of time. Question number 37. Half-life calculation. No background radiation, very easy question. So 10,000 to 5,000 first half-life, and then 5,000 to 2,500 second half-life, and then 2,500 to approximately 1,250. This will be the third half-life. So I can see that it's approximately 2 minutes of half-life in every sector. This is going to be option A. Again, we started with 10,000, divided with 2 because we're looking for the half quantity. 5,000, how much time spent in this? It was 2 minutes being spent for that. Then again, to just re-verify, I divide this again, and we get 2,500. We check at 2,500 and we realize it takes total time of 4 minutes, which means from start to finish, if it is 4, then it has gone through 2 half-lives. So 2 half-lives are worth 4 minutes, so 1 half-life again is worth 2 minutes. Question number 38. The Earth orbits the Sun approximately 365 days. The average radius is this one. Again, a very, very common and repeated question. 2 pi r divided by t. This is r. For example, if this is the Sun, and from the Sun up to the Earth, this is r given to you as 1.5 into 10 raised to the power 11. This is what we put here. And time for oscillation is 365. Now, since this is all meters per second, I need to convert these 365 days into seconds. So this will be 2 pi into 1.5 into 10 raised to the power 11 divided by 365 multiplied by 24 multiplied by 16 multiplied by 60. Once you do that, the answer comes out as 29885 meters per second, which becomes 3.0 into 10 raised to the power 8, probably, no, not 8, it will be 4 meters per second, which is option A. 39. Which statement about the life cycle of star is correct? All stars run out of hydrogen fuel. Yes, definitely. All stars do. A red giant forms a planetary nebula with a supernova at its center. Not entirely accurate. Nebula is formed at a different site. Yeah, it's a different site. It's a different sequence. A white dwarf star eventually forms a black hole. No, it doesn't. A white dwarf is for a light mass, for a low mass star, and black hole is for a high massive star. Most stars expand and form protostars. No, protostar is actually the initial days when the gases are coming together, they're collapsing, they're colliding. A galaxy of distance of this much is moving away from the Earth with this speed. He says calculate the Hubble constant. So first we do that. This is 7,000 equals to h naught multiplied by distance is 3.1 into 10 raised to the power 21 kilometers. Now notice that I'm not changing the sign of kilometers. This is also kilometers. This is also kilometers. I'm not doing that because speed is also required in kilometers per second. And since it is per second Hubble constant and this is also per second, I'm not going to change the kilometers. So h naught from that 2.3 into 10 raised to the power minus 18. Also, if you remember, it's actually 2.2 power minus 18. So it would have, if you had memorized it, you would have immediately figured out that C and D are not possible. It should be between A and B. But anyways, he said there's a new galaxy which is this far away. Find its speed. So V equals to h naught d. 8 is 2.3 into 10 raised to the power minus 18. Multiplied by distance is 6.2 into 10 raised to the power 21 kilometers. Again, not changing the kilometers because we're looking for the speed in kilometers per second. This comes out as 14,000 kilometers per second. It will be option B. I hope you learned something. That is all for today.